Good morning, everyone. My name is Logan, and today I'll be going over my first lab project, which happens to be called FANUC integration. The initial project goal was for a barcode reader to scan the item and send that relevant information to the PLC that would then tell a robot to run a sequence of picking up the object and then moving it to a predetermined spot on the product holder. This, however, would not be the final product of this project, and I'll explain why later. When I first got the project, it was very apparent that it would not just be as simple as programming the robot to do something cool, that it would also need a complete makeover for the wiring as well. The first thing I looked at was the main controls cabinet, which was a complete disaster. There was an apparent lack of planning, and it was not properly set up. There were multiple terminal blocks that were completely unnecessary, as well as a lack of wire ducting to keep things organized. There was also 480 volts coming in the top right next to control wires, which was not okay, but the main issue was the mess of wires running everywhere. To fix all this, I started by removing the cabinet and moving it to a workbench to have an easier time with it. I then removed all the wires and components and started making a new layout that provided more organization and allow easier troubleshooting in the future. While I was out, I also started planning the next piece of this puzzle, and then that was where to relocate the cabinet. The cabinet was originally located underneath the robot on the bottom of the cart, which made it uncomfortable and difficult to work on or troubleshoot, so I needed a better spot for it. The best spot we found was directly behind the robot. Placing it there would require some fabrication and time investment, but the payout would be worth it. To do so, I cut some angle iron, drilled holes into it, and mounted the angle iron to the robot's cart. And then I put the cabinet on top of the angle iron. The process took a few class periods of labor and required running new seal tight to the control panel and as well as the power distribution box, but the end product was worth the effort. The only other thing I needed to do was remove the power supplies from the cabinet. This will allow for room for expansion for the next person who gets this project, as well get rid of the unsafe transformer that was just hanging on the outside of the robot's cart. This brings me to the next cabinet on this agenda, the power distribution cabinet. I need to get rid of the unsafe transformer that was hanging on the side and create room in the main control cabinet, so I killed two birds with one stone and made a whole new cabinet just for power. It has my 480 volts AC to 120 volts AC transformer, which would then feed my 24 volt DC power supply, and this would feed a 5 volt DC power supply that would run my barcode scanner. That's all there really is to this cabinet, and it was pretty easy to do. The last cabinet that needed to be worked on was the FANUC robot controls cabinet. It had the same issue as the main controls cabinet of just kind of being thrown together without much thought. I did my best to tidy it up. I was unable to move it to the bench to work on it better, so it was a little awkward working on it that low to the floor, but I got it done, and it looks a good bit better. This would be the part where I talk about programming the robot and making it work, but unfortunately, this isn't a Disney movie, and not all things have a good ending. The wiring turned out great, but I soon ran into an issue, which was time. It was now time to start my second project, so this one needed to come to an end, which meant the process was no longer an option, so we decided to scale back the project to just overhauling the wiring of it. I will now go over the CAD for this project real quick. The first thing on the CAD agenda is my power supply. As you can see here, it just feeds my network switch, the HMI, my safety controller, my point IO, and a 5 volt power supply. To the right of that, I have my point IO outputs, which control relays. That's to create power separation from the main controls cabinet and the FANUC robots control cabinet. Next to that, it's just the relay outputs to the FANUC's inputs. Pretty easy to look at. And the next to that is the FANUC's outputs back to my PLC. Pretty easy stuff there. Moving on, we have a little bit of a laundry list of things. Reset stuff, e-stops. A lot of little things that need their own rungs. Nothing too much. Moving on to the safety controller, has the e-stops, the reset for the light curtain, the reset button itself, and then these terminals at the bottom feed power to a bunch of different rungs. And it kind of created a safety thing where if an e-stop was pressed or a light curtain was active, it wouldn't allow anything else to be running. So that's good. Below that is the light curtains, emitter, and receiver wiring. I also included the wiring diagram of my trainer in the classroom, which I used for the PLC. So I have that's power supply and its inputs and its outputs. That is all I have for you today. Thank you for watching.